Welcome to the course of differential equation. In this session, we will discuss about the method of undetermined coefficients part 3. We already discussed about the method of undetermined coefficients, that is the method to solve the linear homogeneous differential equation with a constant coefficients and a linear non-homogeneous differential equation with constant coefficients. Here the non-homogeneous part defined by the function r of x. Okay. So, based on r of x we can find this one value of the y p of x. We say that the solution, the general solution of this differential equation is can find by using the formula y is equal to y h plus y p. Here y h is the complementary function and this is the solution of the homogeneous part, is the general solution of homogeneous part, and this y p is a particular solution of this equation 1. Okay. So, correspondingly we will find, firstly we will find the solution of the homogeneous part, that is a y double dash plus b y dash plus c y is equal to 0. Here said there is just a mistake. Okay. C y is equal to 0, that is the corresponding homogeneous part, and then we will find y p. We will find y p based on the r of x, and we discussed it is that if the r of x is equal to c e raised k e raised to p x, then y p is the c e raised to p x, and we already discussed if r of x is the polynomial function, then the choice of y p is also a polynomial function, and if r of x is sin x and cosine of x, that all we discussed. And suppose if r of x is equal to k e raised to p x cos q x or k e raised to p x sin q x, sorry, k e raised to p x sin q x. Suppose if that is any of this form, then definitely we can say that there is a choice for y p, there is a choice for y p as c k e raised to p x cos q x and k e raised to p x sin q x is there. We know that this is choice of y p a sin q x b cos q x, that we already discussed before, and with that we will multiply with a e raised to p x, that is the y p is actually e raised to p x into a cos q x plus b sin q x is there, or otherwise maybe sometimes k cos q x plus this one m sin q x is there, cos q x is there, maybe sometimes a cos q x plus b sin q x is there, no problem. In either case we have to find the value of a and b. Okay. Maybe sometimes this one e raised to p x into p n of x is there. Okay. E raised to p x into p n of x is there. Therefore, we will have e raised to p x into, we have the expansion of y p in polynomial function of nth degree as this one k n x raised to n plus k n minus 1 x raised to n minus 1 plus etcetera plus etcetera plus etcetera plus k 1 x plus k naught. Fine. This is the, if your r of x is of the form e raised to p x into a polynomial, then we can write the e raised to p x into like this. We can find the value of k naught, k 1 etcetera k n. Also one more thing we need to discuss, that we will discuss later. So, dear students, we can have an example for this. this is equal to see if r of x is in either of the form k e raised to p x cos q x or k e raised to p x sin q x, then we can we assume that y p as we assume that y p as we assume y p as e raised to p x into x sin q x plus b cos q x. We will find a and b. Okay, fine, we can move to an example. There is an example 1. Okay, solve the non-homogeneous differential equation. Solve a non-homogeneous differential equation y double dash minus 3y dash minus 4y is equal to minus 8 e raised to x into cos 2x, minus 8 e raised to x into cos 2x. See, I would like to put this as equation number 1. See, my dear students, the homogeneous part we already done before itself. Now see, here this the non-homogeneous part is actually, this is actually r of x. Okay, this is actually r of x. See, dear students, r of x is containing a constant and an e raised to function of the form exponential function into a trigonometric function. So, we can compact to here, see, constant, exponential function, trigonometric function. Therefore, we will have this is equal to e raised to p x, a sin q x and b sin q x is the form of y p. See, dear students, we know that the general solution of this differential equation is, general solution of 1 is actually y is equal to yh plus yp, where yh is the complementary function, that is the solution of the homogeneous part. So, our aim to find yh, consider the corresponding homogeneous equation, consider the corresponding homogeneous equation, and this homogeneous equation will have this is equal to y double dash minus 3y dash minus 4 is equal to 0. We already discussed this equation, that is why I am speedily I will explain this one. Auxiliary equation is actually, m square minus 3m minus 4 is equal to 0. Okay, we have this is equal to minus 4 into 1 is equal to minus 4 plus 1 is equal to minus 3. Therefore, we will have this is equal to m minus 4 into m plus 1 is equal to 0. Okay, fine. Therefore, m is equal to 4 or m is equal to minus 1. Therefore, we will have this is equal to, we can have this is m1 and this is m2. So, therefore, general solution the yh can find by using the formula. Therefore, yh is equal to the general solution of the homogeneous part. This is equal to C1 e raised to 4x plus C2 e raised to minus x. C1 e raised to 4x plus C2 e raised to minus x. So, dear students, now we found the yh. C1 e raised to 4x plus C2 e raised to minus x is there. Now, our aim to find yp, the particular solution, we have the r of x. See, compact our equation 1 and see the r of x is actually minus 8 e raised to x 2x, minus 8 e raised to x 2x, minus 8 e raised to x cos 2x, minus 8 e raised to x say minus 8 e raised to x cos 2x. Fine. Therefore, this is equal to minus k e raised to p x cos q x, e raised to p x into a sin q x plus b cos q x. See, instead of p here we have value 1, instead of q here we have value 2. So, e raised to x cos 2 x is there. Therefore, we will have the value as this is equal to, therefore, y p. The choice of y p is e raised to x is there. So, e raised to x into a sin 2 x plus b cos 2 x. Okay. We have to apply this is into our differential equation. So, that we just want to find y p dash is equal to e raised to x into derivative of a sin 2 x, that is equal to a into the sin 2 x is equal to 2a cos 2 x, that is equal to plus derivative of this one cos, that is equal to derivative of cos is minus sin and 2 x is there. Therefore, 2 minus 2b sin 2 x, fine, plus we have the derivative of e raised to x, that is equal to a sin 2 x plus b cos 2 x into derivative of e raised to x, that is the e raised to x itself. Fine. This is y p dash. See, dear students, this is y p dash and we have to find the y p double dash. See, we need to find y p double dash. The y p double dash is equal to derivative of e raised to x into derivative of this one, and here this is the e raised to the this is first function and this is the second function. Here this is the first function and this is the second function. So, we have to perform this one product rule. So, dear students, y p double dash is equal to e raised to x into derivative of 2a cos 2 x, derivative of cos is minus sin 2 x is there, 1 2 will become 2 into 2 4a minus 4a sin 2 x minus 4a sin 2 x. See, dear students, here we have minus 4a sin 2 x and 2b not sin x, here just a mistake with me, that is equal to sin 2 x. Okay. Derivative of sin is cos, derivative of 2 x is 2, therefore, 2 into 2 minus 4b cos 2 x. Therefore, this is equal to minus 4b cos 2 x, fine, plus the second part is actually the derivative of e raised to x into this quantity. Therefore, e raised to x into by the product rule we can derivative of e raised to x is e raised to x itself 2a cos 2 x minus 2b sin 2 x, 2a cos 2 x, 2a cos 2 x minus 2b sin minus 2b sin 2 x. Okay, again we will have an e raised to x into an e raised to x into this is a e raised to x into second into derivative of first a sin 2 x, derivative of sin 2 x is minus 2 cos 2 x, therefore, 2a cos 2 x, 2a cos 2 x, fine, and 2a cos 2 x and derivative of cos is minus sin. So, minus 2b sin 2 x, minus 2b sin 2 x, minus 2b sin 2 x plus and finally, we will have this one derivative of e raised to x is there and we just e raised to x into derivative of this quantity, and now this into derivative e raised to x is e raised to x itself, a sin 2x, e raised to x into a sin 2x, a sin 2x, a sin 2x plus b cos 2x, a sin 2x plus b cos 2x. Okay, we have yp double dash is here. Dear students, from here we have minus 4a sin 2x, e raised to x is common to everywhere. Therefore, I would like to take this is there, and see consider this one. I would like to 4a sin 2x is here, 4a sin 2x, here we have 4a sin 2x, and see the next sin 2x, a sin 2x, here just an a sin 2x is there, and see have any other sin 2x, here a b a, yeah, this is the minus 2b sin 2x, okay, and minus 2b sin 2x again, okay, fine. So, minus 4a sin 2x plus a sin 2x, okay. Therefore, minus 4a plus a minus 3a, dear students, minus 3a sin 2x, minus 3a sin 2x, see minus 4a plus a, and here minus 2b sin 2x, and here we have minus 2b sin 2x. So, minus 4b sin 2x, minus 4b sin 2x. Okay, fine, dear students. Now, we have an e raised to x into, see, okay, we have an e raised to x into, fine. Now, next one is e raised to x into, we can have the terms of cos, minus 4b cos 2x, see minus 2a cos 2x, and here my plus 2a cos 2x, okay, 2a cos 2x, 2a cos 2x, b sin cos 2x is there. See, dear students, 2a cos 2x plus 2a cos 2x, therefore, plus 4a cos 2x plus 4a cos 2x, and see 2a and finally, we will have minus 4b cos 2x plus b cos 2x, that is equal to minus 3b cos 2x. Okay, fine. So, finally, we will have this one e raised to x into yp double dash is equal to e raised to x into, you can say that this is minus 3a minus 4b into sin 2x, minus 3a minus 4b into sin 2x, and plus 4a minus 3b, plus 4a minus 3b cos 2x, plus 4a minus 3b cos, plus 4a minus 3b cos 2x. Fine, this is equal to, so this is yp double dash. Now, we can apply this all values in, apply in our differential equation, that is our differential equation is actually, the students, come back to our differential equation, y double dash minus 3y dash minus 4y is equal to minus 8 e raised to x into cos 2x, y double dash minus 3y dash, y double dash minus 3y dash minus 4y is equal to 8 e raised to x into cos 2x. See, y double dash minus 3y dash minus 4y. is equal to minus 8 e raised to x into cos 2x. Minus 8 e raised to x, minus 8 e raised to x into cos 2x. Y double dash minus 3y dash minus 4y is equal to 3y dash minus 4y. 3y dash minus 4y is equal to minus 8 e raised to x into cos 2x. Minus 8 e raised to x into cos 2x. Okay. So, we can apply y double dash, instead of y double dash we can apply yp double dash. Therefore, yp double dash, here we have this is equal to, that is e raised to x into, we will have minus 3a minus 4b, minus 3a minus 4b sin 2x. Okay. See, while seeing itself is a little lengthy, no problem, but we can understand this one. This is equal to minus 3a minus 4b into sin 2x plus 4a minus 3b cos 2x, fine, and minus 3y dash, come back to y dash. See, here we have y dash is here, and while seeing y dash, see yp dash 2a cos 2x and b cos 2x is there. Therefore, e raised to x into a minus 2b sin 2x, e raised to x is there. So, we can say that that is equal to plus, sorry, minus 3 e raised to x into, see this, minus 3 e raised to x into y p dash is equal to a minus 2b sin 2x, a minus 2b sin 2x. A minus 2b sin 2x. See, a minus 2b sin 2x, and one more thing here it is that this one 2a plus b into cos 2x, 2a plus b, see 2a plus b, okay, 2a plus b into cos 2x, 2a plus b into cos 2x, fine, and finally minus 4y, therefore minus 4 into e raised to x into, finally we will have this is yp, yp is equal to e raised to x into a sin 2x plus b cos 2x, a sin 2x for a sin 2x plus b cos 2x is equal to, we will have, finally we will have minus 8 into e raised to x into cos 2x. See, dear students, everywhere on the left hand side and right hand side there is a term of e raised to. You can take e raised to x is outside. So, while taking e raised to x is outside, this all e raised to x will be there in outside, therefore, we can cancel. Finally, we will have the terms of this one, see sin 2x is here, therefore, the terms of sin 2x, okay, we can adjust this as, see it sin 2x, write the coefficients of sin 2x, the coefficients of sin 2x as, see the e raised to x is not there, therefore, sin 2x minus 3a minus 4b plus minus 3a, here one more minus 3 is here, we just multiply this minus 3 to here and here. Therefore, we will have minus 3a minus 3a, okay, minus 3a minus 3a, therefore, we will have minus 6a, and also minus 4b minus 6b minus 10b, okay. So, minus 6a minus 10b sin 2x, minus 6a and one more minus 4a is there, minus 3a minus 3a minus 6a minus 6a minus 4a. So, this is equal to minus 3a minus 3a minus 6a minus 4a minus 10a minus 10a minus 10b sin 2x minus 10a minus 10p sin 2x minus 10a minus 10b sin 2x plus we can have here it is the cos 2x. See, find the coefficients of the cos 2x. See, dear students, here we will have 4a minus 3b cos 2x. Okay, we can multiply minus 3 into this one 2a. Therefore, minus 3 into 2a minus 6a minus plus 4a minus 6a. So, we will have this is equal to plus 4a minus, just a minute, one more thing it is here, minus 3 into minus 2, therefore, plus 6. So, minus 4b plus 6b is here, okay, minus 4a plus 2b, okay, plus 2b, yeah, sorry, here I just checked simple mistake here, minus 4b is here, minus 3 into minus 2 minus 6b, minus 4b plus 6b is plus 2b, plus 2b minus 4b is here, therefore, we will have this is the plus 2b minus 4b, therefore, minus 2b is here. So, instead of this 10b, here we will have plus this one minus 2b, sorry, minus 2b. See, that is fine. See, minus 3a is minus 6a, minus 4a is minus 10a, minus 4b plus 6b plus 2b minus 4b is again minus 2b. Similarly, here we have minus 4a, minus 4a minus 6a, sorry, plus 4a minus 6a, minus 2a, minus 2a and minus 2a minus 4b. So, minus 6b. Okay. See, just I repeat again, 6a 6a cos 2x and minus 3 into 2 4a cos 2x in minus 3 into 2 minus 6a cos 2x. So, 4a minus 6a minus 2a cos 2x. Okay, fine, minus 2a cos 2x is there. So, we will have here minus 2a cos 2x. So, minus 2a and again we will have C minus 3b cos 2x, minus 3b cos 2x minus 3 into b. Therefore, we will have minus 6b, minus 3b and minus 3b minus 6b, minus 6b in plus minus 4b, minus 10b cos 2x. So, minus 10b. Okay, fine. So, the terms are there. We completed all the terms of sin 2x, cos 2x. Here we exhausted this one, we exhausted this one, we used this one and we used this one. Finally, we will have here it is equal to minus 8 cos 2x. Fine. So, this is equal to minus 8 cos 2x. Fine, we found the values. Okay, minus 8 cos 2x is there only in the RHS. So, we have this is equal to compare, we can compare the coefficients of the sin 2x, compare the terms of sin 2x, compare terms of sin 2x. Therefore, we will have this is equal to minus 10a minus 2b is equal to, in RHS there is no term of the sin 2x. Therefore, we can say that this is equal to 0. This I just put equation A. See, dear students, and again we can say that this is equal to compare terms involving cos 2x. See, we will have minus 2a minus 10p equal to here we have the coefficient of cos. Therefore, cos 2x that is equal to minus 8, that is equation B. See, minus 10a and minus 2a is here, minus 2b minus 10b is there. no coefficients are equal, therefore, we can multiply b with 5. We can multiply b with 5, multiply we will multiply we will multiply b with 5. Okay, we will multiply b with 5. Fine. While multiplying b with 5, we will have this is equal to minus 10a minus 50b is equal to minus 40. Minus 10a minus 50b, we will multiply with 5, and minus 5 into a minus 8 is equal to 40. Therefore, minus 50b c minus 50b is equal to minus 40. This is equation C. I would like to write again a, that is equal to minus 10a minus 2b equal to 0. Minus 10a minus 2b equal to 0. This is equation A. Minus 10a minus 10a c here, sorry, minus 10a minus 2b equal to 0. Okay, fine, dear students. Here we will have minus 10a minus 2b equal to 0. I just like to subtract a from c. See what will happen. Here we will have minus 10a minus minus 10. So, plus 10. So, this is equal to 0. This is equal to 0, and here we have minus 50b minus minus 2. Therefore, minus 50 plus 2, therefore, minus 48b is equal to minus 40 plus 0. Therefore, this is equal to this is equal to minus 40. Okay, fine. Dear students, now we got this is equal to minus 48, b is equal to minus 40. See, b, therefore, b is equal to 40 divided by 48. So, this is equal to, we can cancel by 8, therefore, 5 into 8 is equal to 40, 6 into 8 is equal to this one 48, 5 by 6 is there. Put b is equal to 5 by 6, b is equal to 5 by 6 in equation A, in A. So, we will have minus 10a, dear students, see, minus 10a minus 2b, minus 2 into b is 5 by 6 is equal to this one 0. Fine. So, we will have this is equal to 10 minus 10a minus 2 into 5 by 6 is, we can cancel 5 by 3. 5 by 3, okay, we can cancel, and this is equal to 0. So, minus 10a equal to 5 by 3, minus 10a is equal to 5 by 3. Therefore, a is equal to minus 5 divided by 3 into 10, and we can cancel this 10 and 10, we can 5 and 10 we can cancel 2. Therefore, this is a is equal to minus 1 divided by 6, a is equal to 1 by 6. Now, we found, dear students, we will have the value of b, we found b is equal to 5 by 6, b is equal to 5 by 6. Okay. Therefore, we found yp, therefore, we found yp, hence yp is equal to, we have yp is equal to, therefore, yp is equal to e raised to x into a cos 2x plus b cos 2x. See, therefore, yp, dear students, we have, therefore, yp is equal to, therefore, yp is equal to e raised to x into a cos 2x plus b, sorry, a, we discussed here it is sin first, therefore, a sin 2x plus b cos 2x. Am I right? We started with that one. Okay. A cos, see dear students, a sin 2x plus b cos 2x. Okay. Fine. Therefore, we will have, dear students, we have the value, that is the a sin 2x plus b cos 2x, b cos 2x. Fine. Therefore, we have the value of, that is yp is equal to e raised to x into the value of a is minus 1 by 6 sin 2x plus b is actually 5 by 6, that is the 5 by 6 cos 2x. Hence, the general solution of the given equation is, therefore, general solution is, therefore, general solution of general solution of the non-homogeneous differential equation is, non-homogeneous differential equation is, general solution of the non-homogeneous differential equation is y is equal to yh, y is equal to yh plus yp, y is equal to, sorry, y is equal to yh plus yp, y is equal to yh plus yp. Now, therefore, y is equal to the complementary function yh, we already found yh before itself, that is actually yh is equal to c1 e raised to 4x plus c2 e raised to minus x. Yh is equal to c1 e raised to 4x plus c2 e raised to minus x plus, see here we have e raised to x into, so minus e raised to x by 6 into sin 2x minus e raised to x by 6 e raised to x divided by 6 into sin 2x plus 5 e raised to x divided by 6 into cos 2x. See, plus 5 e raised to x divided by 6 cos 2x is there. That is the general solution of the given non-homogeneous differential equation. Now, we found it. Okay. So, the students, this is the way to find the solution of the non-homogeneous differential equation by using the concept of the method of undetermined coefficient. Here we used the method to find yp by using the choice of yp, as here we have r of x is the as a combination of the exponential function and trigonometric function. Therefore, the choice of yp is e raised to px into a sin qx plus b cos qx. So, as we did before, we just we will try to find, we will find the solution of the homogeneous linear second order differential equation. After that, we will find yp and yp dash, yp double dash, we just apply it to the given differential equation, and finally, we are able to find the value of this one a and b, and we will get yp, and also finally, we will have the general solution of the non-homogeneous differential equation. So, here you can find many interesting questions in the literature of the differential equations. So, you may try to solve more questions from this area. Thank you for watching these videos. Continue watching. Thank you very much.